Good day, viewers. You're welcome back to my channel today. Please, if today is your first day of visiting this channel, please subscribe to this channel and turn on the notification bell so that you'll be notified anytime we upload new videos. Today we're having the following golden equation. Okay, why this equation is called the golden equation is that the root contains the golden ratio, which is known as 1 plus root 5 all over 2. So this is the expression for the golden ratio. Okay, now how do we solve this problem? Before we continue solving this problem, we need to record the following identities: that x minus 1 over x in bracket squared is equal to, in bracket, x plus 1 over x squared minus 4. Okay, so this actually means that this we're going to represent this, so using this identity here. Okay, so we have here 5 open bracket x plus 1 all over x is equal to, so instead of writing this x minus 1 over x squared, so we replace it with this, so we have x plus 1 all over x squared minus 4 and then plus 10. Okay, so here we have 5 open bracket x plus 1 all over x is equal to, simplifying, so we have x plus 1 all over x squared. Negative 4 plus 10 is positive 6. Okay, now we're going to take our substitution from here. So what is the substitution we're going to make here? So nothing changed when we make the right hand side of this equation to go this side and become the left hand side, and this one becoming the right hand side. Okay, so I will write the equation as follows: x plus 1 all over x squared plus 6 is equal to 5 open bracket x plus 1 all over x. Okay, now we're going to make the following substitution. So we can say let x plus 1 all over s equals k. Okay, so after making this substitution, so we have k squared plus 6 is equal to 5k. Subtracting 5k from both sides of this equation, so we have k squared minus 5k plus 6 equals 0. This equation is factorizable. Okay, how do I factorize it? So I'm going to write negative 5k as follows. So I will write as follows: a k squared minus 2k minus 3k, so minus 2k minus 3k is negative 5k, then plus 6 is equal to 0. So from here I'm going to factorize, so I have k factored out here, so we are left to k negative 2, then minus 3 should be factored out here, so I have k minus 2 equals 0. So from here I have k minus 2 is equal to 0. Okay, let me write in a factorized form. So I have k minus 2 in bracket and another bracket again, k minus 3 equals 0. Okay, now from here, we have k minus 2 is equal to 0, or k minus 3 is equal to 0. So from here now we get k is equal to 2 or k is equal to 3. Now let us go back and recall that we made a substitution in terms of k as x plus 1 all over s is equal to k. Okay, now here we have when k is equal to 2, so we have here x plus 1 all over s is equal to 2. So multiplying both sides by x, so we get x squared plus 1 over s times x. Here we are left with 1 equal to 2 times x, so 2x. Okay, so we have here x squared, subtracting 2s from both sides, minus 2x plus 1, okay, is equal to 0. So I believe this is factorizable again, so I'm going to write negative 2x as follows: x squared minus x, so then plus 1 is equal to 0. So factorizing this here, so factor out x, so I have x open bracket, x minus 1, then minus 1 open bracket x minus 1 is equal to 0. So this is in factorized form as x minus 1 times x minus 1 equals 0. So we can see that we're having a repeated root here, so we just take one of it, so we have x minus 1 is equal to 0. Therefore x is equal to 1. So this is the first value of x. Okay, now don't forget that the other value of k is 3. Okay, so we now say that when k is equal to 3, okay, so we're having x plus 1 all over s is equal to 3. multiplying both sides by s and simplify, we have something like this: x squared minus 3x plus 1 is equal to 0. So this is not factorizable. If we want the coefficients to be like, well, let me say this is not factorizable over the over the integral values here. So like expressing it of this form, x minus 1 times something of x minus 0, just like integers. Okay, so now what I'm going to do here, I believe the roots of these equations are going to be irrational roots. Okay, so let me see what I'm going to do. Let us introduce the general quadratic formula. The form of any quadratic equation is ax squared plus bx plus c is equal to 0. This has a solution as x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, now in the equation, x squared minus 3x plus 1 is equal to 0. So comparing here, I think we have a is equal to the coefficient of x squared is 1, b is equal to the coefficient of x is negative 3, and c is equal to 1. So the equation will be having the following roots: x is equal to, negative b is negative 3, so 3 plus or minus square root of b squared is negative 3 squared in brackets, because negative 3 squared is not the same as open bracket negative 3 close bracket squared. Okay, so before we square b, so we need to put this in bracket and square it. So we get 9, then 9 minus 4 times 8 times 1, so we're having 5 here over 2. Okay, so now we have here, so we can say here x is equal to 3 plus root 5 all over 2, or here x is equal to 3 minus root 5 all over 2. Now look at this root here. So it's the same as 1 plus, the Gaussian ratio, 1 plus square root of 5 all over 2. So, the symbol representation of this Gaussian ratio, we have 1 plus something like this, so like phi. Okay, so we have come to the end of this today's video, that x is equal to 1 in the above equation. X is equal to 3 plus root 5 all over 2, and finally x is equal to 3 minus root 5 all over 2, having 3 real values. Thank you for viewing, and please make sure you subscribe to my YouTube channel for more interesting videos. Bye bye.